Hello, this is going to be a quick video on differentiating ax to the n from first principles. So I'm sure as many of you know that if you have f of x, which is equal to ax to the n, then the derivative of that would be an x to the n minus 1. So for example, if f of x is equal to 2x cubed, then the derivative would be 6x squared, and that's basically if your a is your 2 and your n is your 3, you're bringing the power down and you're taking away 1. Okay, but a lot of people don't know why this actually works, so let's show you how. So, I'm sure many of you know that the derivative is written as this function here. So the limit is h tends to 0, f of x plus h minus f of x all over h. So let's say our f of x is ax to the n, and this is general, so a can be anything and x can be anything. And then our f of x plus h would be a x plus h to the n. So let's put it into our expression and see. Limit is h tends to 0, a x plus h to the n minus ax to the n all over h. Now we can factor out an a, which leaves us with x plus h to the n, take away x to the n all over h. Now, if you know the binomial expansion, although we can't write out all the terms, we can start doing some. So for x plus h to the n, it will be x to the n plus n choose 1 h, x to the n minus 1, plus n choose 2 h squared, x to the n minus 2, and on and on and on, and we also have the minus x to the n all over h. Now, the first term here, you can see cancels out with this, so we basically get left with limit as h tends to 0, a n choose 1 h to the n minus 1 plus n choose 2 h squared x to the n minus 2 and on and on and on over h. Now, you lot should probably see that this would cancel out, leaving just h, and all of these terms would lose 1 power of h on the numerator. So you get left with n choose 1 x to the n minus 1 plus n choose 2 h x to the n minus 2, and that goes on and on and on. So let's look at this. N choose 1 is just simply n, and then we can write this as, actually we'll do that later, but let's look at this. So as h tends to 0, all of the terms you see here, h, and the next one will have a h squared and on, they all tend to 0 too. So what we really are just left with is a n choose 1 x to the n minus 1, because that's the only term that doesn't contain a h from this continuous series here. And then I'm pretty sure you know that n choose 1 of anything is just equal to n. So as in 2 choose 1 is equal to 2, 3 choose 1 is equal to 3. So this is just equal to an to the x minus 1, and that is it. Thank you.